Direi di chiamare sul palco il secondo co-organizer di oggi, Jacopo Nardiello.
Ciao a tutti, ciao Edoardo.
Ciao Jacopo.
Ciao, allora, niente, io sono Jacopo Nardiello, sono un CNCF ambassador e sono appunto il founder di SICAP. Vado a procedere a introdurre Anna Maria.
Vai.
Okay, so switching to English. So the next speaker is actually Anna Maria Milcinau, and I hope that I pronounced the surname correctly. So Anna Maria is a Java champion, developer advocate at Redhat, and the co-founder of the Bucharest software craftsmanship community. She's going to talk about resiliency patterns in cloud native. So Anna Maria, we are super excited to have you. Thank you so much for being here. The stage is yours.
Hello, and I'm happy to be here as well. I'm really honored to be at the first edition for KCD Italy. And yeah, watched very closely the talk before me. It was really, really interesting. I do understand a bit of Italian thanks to my roots, so that's a good plus. However, the talk will be in English.
That's great. So please, thank you so much.
Thank you as well. So everybody, welcome to my talk, Cloud Native Resiliency Patterns from the Ground Up, and just going to dive into the talk itself. If you have any questions during the talk, please post them in the Q&A section. I will try to answer as many as possible. So first of all, who am I and why I'm here? As said earlier, I'm Java champion and a certified architect, and working currently as a developer advocate for Redhat. But what I need to share with you is that I started as a Java developer, that's true. However, several years ago, I became very attracted to the containers world and to Kubernetes. So I discovered a second passion with Kubernetes. I certified the second passion for Kubernetes with various certifications as well. And I love to try new things, and probably this is why we're having this conversation today in this talk. And I also like to have control. Probably that's another reason why I was drawn to Kubernetes, because Kubernetes was giving me the ability to control what's going on with the deployment of my application. And it seemed to maintain and contain easier what was happening with my app compared to my previous experiences on deploying on application servers and working with virtual machines. So that's pretty much about myself. And in the talk of today, we're going to look a little bit of how we can avoid delays and denials in our applications. And of course, the first place where we would like to look into is defining a little bit the resilience. Now, resilience, there is a definition about it. I don't want to dive into the definition today. I just would rather have it depicted from the way I perceived resilience. So our application typically is in this normal behavior here, right? The developers, let's say, the developers coded it really, really well. It was deployed, it works perfect. However, sometimes unexpected conditions occur, And in our normal behavior of the application, it turns differently, and it starts having unexpected events inside it. These unexpected events actually trigger next a faulty behavior. Our application gets into faulty behavior. However, thanks to detection control mechanism, we can recognize that malfunction. We can get a feedback and have a feedback control to mitigate that malfunction. And afterwards get into a so-called degraded mode behavior for our application. So our application will be not responding as usual, but in this degraded mode, we also have options and patterns, and we're going to look into those, to offer a similar experience to the end user, that everything is going okay, via the recovery control mechanism that can either give a similar experience to how the normal behavior would be, and afterwards restore the expected behavior for the app. So this is pretty much my view on resilience. However, we cannot control unexpected conditions and sometimes the unexpected events that occur in our applications, but we can control three things: the mechanisms that are used for detecting the not so nice situations, the feedback control mechanism, and the recovery control. And these three are actually can be implemented at various places in our applications. The first place that we start to look into, and that I'm going to code a bit to show you how it's going on there, the first place where you start with fixing things in case of failures, and you're preparing yourself for failures, is at application level. And probably most of the Java developers would have read Martin Fowler's blog, and where this nice picture is coming from, regarding the circuit breaker pattern and how it works at application level, and not only. And that's where I will start as well. So without further delay, let's go a little bit into the code. I've coded 2 microservices for today because I'm going to use them in my example and what I want to share with you today. And these microservices are based on Quarkus. They work perfectly most of the time. And in my first microservice, the one called activity, is actually a microservice where I am consuming information from an interesting API. Not sure if you know about it. The board API is the API that gives you like ideas for activities when you're feeling bored, and you can also select participants and so on. So what I'm going to do in my first microservice, I'm going to consume information from this board API, and in my second one, I'm just going to have a very nice UI that to display these board API activities. And we'll try to make this these two systems resilient with different options available. So the board API, typically we would say that is, functioning correctly. And if I'm going to my activity microservice and I am starting my Quarkus app, don't worry, it's not going to be a Java. This is just the beginning of our patterns. Things are going to be looking really, really nice for me. My application is going to start. It's probably everything will be great. So if I'm going to my browser, sorry about this, and say localhost, I think it's on 8082, this one. And I'm going to my dev UI. My app is going to be really, really working fine. Let me try out an activity here and say music, and execute this. Okay, so I'm getting some activities, all is good. However, let's simulate a problem. And I'll simulate this by using a random URL so that this thing will not work anymore. Let's execute again. Now, without this way to mitigate this problem, that's what our end user would see, like these lovely unhandled exception. So without doing something in between, our end user will see this. At the app level, there are several options available. So just to quickly introduce you what we can do at the app level, because the app level is the first place where we can mitigate problems, I'm just going to add a few things. So first of all, I'll add a circuit breaker annotation over my methods to mitigate the problem. And on this one, with a circuit breaker, what I can say, like, okay, at what percentage I want to open the circuit. I want to stop things from showing failure to my end users. And I can say 75%. However, it's a good thing for me to retry, because maybe things are not working at some point in time. But it would be good to have the circuit in half open and maybe open it if in half open and then close it afterwards when things are back to normal. So maybe I want to retry again in 1 second. Next, when it comes to consuming information or systems that do not respond, at least at application level, you should be looking at how much time that response, how much time it's taking for a response to be obtained. So let's mitigate a bit the timeout part. and say, hey, I do not want to like wait more than 250 milliseconds so to see if something is retrieved or not from this consumed API. Now, when timeout fails, is great to like is great to see that something is wrong. And timeout is throwing a timeout exception, which can be used by another annotation that's retry. And what retry does is like still believing that things can be fixed. And it can say max retries, and of course, retry it every 100 milliseconds. So what these three together do, it happens the following. Like when 3 out of these 4 fail, it will trigger this one. Of course, 3 out of these 4 retries with a delay of 100 milliseconds, and it will trigger this one. But the circuit breaker with this delay will be like, yeah, but I will try again like in 1 second. So maybe the things are working better. But this is not enough for end users. And sometimes we're using fallbacks so that we can show something to the end user. You know, that recovery thing, so we can simulate at least something for the end user until some information is obtained, or to give that to the consuming or the front end, like to show something to the end users. And I've used the default basic hobby for that one. And my default basic hobby is just returning an empty hobby. Now let's go again to this part here and execute it. Now we don't see the lovely exception that we saw earlier. Now the response is like having participant 0, price 0. It has some information there about this activity. It's not as great as the real thing, but at least it gives the users some information that is more nicer to see, or maybe it gives more something more appealing to be interpreted by front end or other applications that are orchestrated in the ecosystem of my microservice, right? So this is the application level. Now let me like restore this one and stop this one here. And by the way, this because we're like a Kubernetes cloud native conference, this microservice is using the native image to be deployed. So everything is very native around these implementations today. So this is the place where to start at the application level. And for those of you like interested in looking into this at the application level, I have produced for you a sequence diagram like between activity service and the external API, so that you would see how the sequences are being done between each annotation and how things are happening inside the app. But we are at a Kubernetes event, so let's look at infrastructure, right? And go to the serious stuff. At the infrastructure level, we're using most of the time proxies for obtaining the resilience and for controlling things. And of course, there's some available patterns for these proxies. We have service discovery, and service discovery is something that, well, we can rely for what is available in Kubernetes, or we can improve on that. Of course, there's load balancing. And we can use external load balancers even for balancing the load when things are like becoming very, very heavy to be handled by our applications. So Kubernetes is like giving a nicer layer, an extra layer of security to our app. And of course, we go into more serious stuff with circuit breaking, with retries and deadlines, even at the infrastructure level. And that's the beauty of blending all together at the application and at infrastructure level. And well, a third pattern, probably many of you have tried it or you would like to try it, is load shedding. And we're going to look into these at infrastructure level and see how we can build upon our app. First of all, locality, load balancing, and failover. The easiest to do that, from my perspective, is like using Istio. Istio is there to help us with a bunch of additional resources that can improve on what Kubernetes is giving to us. So in my example, I've used the gateway configuration so that my requests coming to my microservice would be like afterwards manipulated by the gateway. I've used a destination rule because I would like to a balance between two versions, two deployments of my app, and of course a virtual service to help me into routing the request. One thing that I would like to show to you is I've used the locality load balancing and failover that's available in Istio. So in case in this case, when I'm going to deploy V1 and V2, let's say something bad is happening to V1. In this case, just by using destination rule and having the locality load balancer setting enabled with failover, I can make sure that if V1 is not available, then V2 is actually going to handle the request. And this locality LB setting with a failover is something that application developers have been searching also in regards to Istio, because some time ago, a friend of mine asked me hey, okay, we have this fallback at application level, but how does Istio do that? Can Istio do fallbacks? Well, a failover is kind of similar to the fallback that we have in Istio. But moreover this, when we're looking to circuit breaker with Istio, we can add a little bit more. And we can have not just locality LB setting with a failover. We can also have the outlier detection that helps us into detecting the not so nice situation, the 500, those 504 situations. And when this is happening, then together with the failover, you have a smooth transition from the not functioning to the functioning situation. And let's look in some details and do some real coding, not just talk. So let me go to the resilience. By the way, the repo will be shared with you, so do not worry. And I'm going to use my examples in this demo so that you would know how to run them afterwards if you're interested to simulate things. First of all, let me simulate how would the part with the failover enabled would be looking like. And first of all, let me go and kubectl, actually OC project. I'm using OpenShift for these demos, but also my examples work in Minikube. I've tried them as well. So first of all, I need to deploy my apps. And I have coded several backends. I've also configured a backend faulty probe. I have my gateway, Istio gateway, and also need to export my gateway URL. And of course, let's apply the virtual service with the failover, just for those of you to see and to trust that I'm doing the right thing. This is just with the failover, the simple round robin from V1 to V2. And next one, let's go with the virtual service. Okay. Cool. Now, let's go to the browser, and I just want to look a little bit in Kiali. And okay, I have my application deployed. Display some idle nodes for me. So I have my V1 and V2. I just want to make sure that, okay, activity is not failing anymore. And I just want it to fail a bit. So let me invoke a small failure to it. In my YAML. Healthy living, timeout seconds. Okay. I'm just going to give some ridiculous numbers here. Mhm. Okay. And maybe this will be enough. Okay, yeah, it's red. It's good. Let me quickly go and do some invocations. I just want to make it bad for a moment so that you can see what's going on. I pretty much like to simulate with Kiali in my bad situations, and I hope that in this case it will work. So pretty much when V1 is not available, the traffic will be directed to V2. And why is my traffic animation not starting? Oh yeah, it's already stopped. Let me do the bad thing again. Sorry about this. It's always like that when you try to simulate bad things, and it's not the case, you know. And okay, let me do this. Save. Go with Siege, and hopefully now. No, I don't. Okay, now it's going. It should be bad. Although Kelly is like showing totally different form at the moment. Always didn't got everything. What I wanted to show to you is like things are being routed only to V2. Yes, things are being routed only to V2 when V1 is not very stable. Let's stop this one for the moment and improve with the circuit breaker. First of all, let's go back a little bit and like remove even the failover from the situation and compare a few things. So if we're like to remove the failover and just be like simple simulation of this and just, you know, route the traffic between the two. I think I should be like keeping both backends okay. And say kubectl get deployments just to make sure that everything's up and running. So everything seems to be okay. If I'm invoking an endpoint that is not like in the best shape ever, this one is like giving me timeouts. What's happening when concurrent invocations occur over this endpoint? You can see that my endpoint responds with a 504, but it takes an awful amount of time for it to like give me some information. I mean, 2 seconds in this or 4 seconds in this lifetime is an awful lot of time. So this is not very nice. And we can see that it took like 23.2 seconds to do all these failed situations, which is not nice. However, thanks to circuit breaker pattern that is available with Istio, with the outlier detection, with the failover and everything, the same situation, like there was like 23 seconds earlier, and let's do the same call. You just can see that, well, first of all, the 504s that were like interpreted from the application level, because that was what the application was sending, 504s. Thanks to the circuit breaker pattern with Istio, you get 503, so that's the standard coming from there. And you can work with the 503s and always rely on those, like when you're like orchestrating things. But not only this, you see that the response is 0.something seconds, which is way better. We know in 2.47 seconds that our system is not working as expected. The longest transaction is 2 seconds, point something seconds, which is way better. So in our world, well, if things are not going that great, it would be better like to fail fast, not to wait for a long time. And Istio is there to support us really great at Kubernetes level, and works really nice also together with coding at application level as well. Now, this is one way to like handle the problems, you know. So if in case something is not working as expecting, or it takes longer as expected in responding, you can have this control at your infrastructure level. But not only this. However, if you like using multi-zone deployments, you can also rely on other mechanisms and other options to like orchestrate the failover mechanism. Like when something is not going on really well with something on your in a cluster, maybe you can respond with an application deployed in another zone in another cluster. And for my simulation today for failover, I've also wanted to try Scooper. Scooper is working at a layer 7 regards connecting networks across clusters, and is great. There's also another option, I think is working at layer 5. It's called Submariner. So you can try that one as well. However, you have a little bit more configurations with Submariner than with Scooper. What I love about Scooper is that it's easy to be initialized and deployed across different clusters or across different namespaces. It's because Scooper can work also across different namespaces to like orchestrate a failover, and you can also have HTTP load balancing with it. In my simulations today, I've just used 3 namespaces because I just wanted for this kind of example to be reproducible, also Minikube without using the tunnel, the tunnel functionality. So like you could use it together with that. And you can see that a Scooper is there to act as a proxy when something is not, to act as a proxy to the actual real backend. And if the backend is having a problem in a connection issue, to talk to the other Scooper instantiated in another namespace or another cluster and get those informations from a responding service. Those being said, what you see here is that I have another thing deployed. It's called front end. And yes, in my cluster, let me go here. I have deployed in 3 different namespaces my application. I've done the front end. I kept it in the Benelux namespace or Benelux project. CE has only a backend deployed, and there's another one called UKI, also deployed here, and all these 3 are connected via Scooper. And just as a heads up with how it was connected via Scooper, you have, by the way, all the details for my setup here. And also, by the way, with kubectl commands so that you can reproduce it. How I've used it, well, it was easy. I just had to annotate my service, my backend in all the clusters or the namespaces or clusters, depending on how you're trying to set it up. And then I pretty much initialized Scooper in the namespace that has, the front end. I put the console authentication to unsecured, but you can also have like this Scooper console where you see nice things secured as well. And I just simply created a token. This token, what it does for me, it says like, okay, you can use this entrance token to like connect your deployments across namespaces / clusters. So by just using Scooper init and Scooper link and others in other namespaces, I'm able to interconnect my backends without doing anything really complicated regarding, I don't know, certificates or making other secrets and so on and so forth. So Scooper is this lightweight. Of course, do not forget to annotate. So Scooper is working very much with the annotation for this one. So that's another important aspect of it. But just by using the same token.yaml, I can do this in an endless part of namespace. So this is the power of Scooper. And just let's look at it. Okay, I think I'm in Benelux, I hope. No, I'm still in activity. If I'm going to my Benelux, where I have the front end and my routes here, if I'm going to hobby front end, for the moment, I see that there's no workers. But what I'm going to do, I'm going to ask for some requests that will be mediated by Scooper. And speaking of this, let's look a little bit to Scooper's 6 routes, Cooper, I think. Yeah, this should be yes. This is the console, the one that's unsecured at the moment, and you can see my 3 deployments. Currently, no request has been done. Let's make some requests to our cluster, so to our deployments. And you can see that Cooper is going to try to serve it from Benelux, which is closer. However, if there's a load, you can see that it's responding also from CE and UKI. So if there's like too much ask, Cooper can balance that as well. And you can see how many requests, of course, have been done and which requests were routed to where. Maybe the UI is not, can do it. Yeah. Okay. So you can like see what's going on with your requests across this. Another thing that I like with the failover with Cooper is like if I'm doing, let's go to the deployment and scale it to 0, like not having it available anymore. And since I think I've already have killed this the Benelux one. Now, next requests are going to be requested to the available places. So you see that's getting things from CE and is not touching Benelux anymore because it has nothing available there. So failover can be orchestrated even with other options in the cloud native space. And of course, I will quickly go with you through load shedding. Load shedding, of course, drops some traffic and drops a proportion of traffic as the server approaches overload conditions. This is the definition from the Site Reliability Engineering book. Probably you've read it and you've went through it, and it's an interesting subject. One subject that can be touched with from the load shedding is that you can do rate limiting with token bucket, and you can do that at application level. And I coded that part for my limited endpoint. In my application with something called Bucket4J. How Token Bucket works is that it's handling incoming requests. Well, when incoming request is coming to our endpoints, let's say, that request is checked against the bucket size. And if the bucket size is full, then that request is either dropped, prioritized, or sent with low priority. Drop should be like the last resort. Most of the time, things are prioritized by, I don't know, HTTP headers, or you have some sort of algorithm to prioritize the request. You don't want to drop things, and you don't want to drop requests of your users. It's better to sometimes serve them later than just dropping them. If the full bucket was not like reached, you can send the request because your app is like going on like nothing happened. The bucket can be refilled because, you know, you are comparing the incoming request with the bucket size, but this is not like an infinite thing. So when the bucket is full, that's it. No more requests is being handled. That's not the right thing. So what you do, you can refill the bucket, and you can calculate the duration to refill that bucket by using the bucket size over the refill rate that is available there. Also, a nicer way to like look at rate limiting. So Istio is also coming with options to implement rate limiting, and those are available as well. But you can also do concurrency control based on request priority with Istio. And the way to do that is most of the time by using either headers, and you can use the baggage user agent, like from which browser the request is coming, and you can like prioritize lower based on that. So for example, it can happen that maybe your end users, you don't have a big pool of end users using Safari and like asking for your services. And in this case, you can like give them a lower priority and give to the others a bigger priority. I'm not saying to drop, I'm saying just to like give a lower priority, or handle them differently so that they are not being put so much load on your app when you are like having high traffic. How about autoscaling? Because we've been talking about these things of like handling load, handling failure. But sometimes when you're like thinking of handling load, isn't there autoscaling available in Kubernetes? And why is that not enough for handling load, for example, to make an application resilient? What you can do, from my point of view, is like you can interplay autoscaling with load shedding. So let's say you have this autoscaling condition here. What you can do is when requests are coming to your app and where your workload is increasing, and you feel that you're approaching the autoscaling, you can have the load shedding kick in to reduce the resource stress, and that will be nice, for app. Once the resource load shedding is happening, but as you saw earlier for the token bucket algorithm, there's a duration for which load shedding is applied. So load shedding will stop at some point. You don't want to apply it for a longer time. That's when you should look at the situation. Does the increased traffic continue? Because if the increased traffic is continuing over time, then in this case, you should trigger autoscaling, or you should trigger the scaling mechanism so that you are, actually instantiating a new pod, or you have a new deployment scale there, so that you can handle things with for your users. So always look at how much time the bad things or the workload is under stress. If things are not that bad, or the low traffic is lower, then the autoscaling condition, then you can get to the normal situation. You can assume that things are normal, so no more load shedding, no more thinking about autoscaling. Everything is back to normal, so everything is great. However, this is how I would say that autoscaling works great with the load shedding, but always keep in mind about the conditions and how you can reduce stress with both of them. Thank you very much for listening to me. The code is made available to Umbra/Resilience. And I hope I'm not over.
Yeah, here I am. And ciao, Anna Maria. Wonderful talk. And thank you for being here today. We're running out of time, so I'm trying to be quick with a couple of questions. Okay. And the first one is from Cesare, just one maybe. Who provides all those fancy annotations like the @circuit breaker, like Spring or Quarkus?
It's Quarkus. I've used Quarkus for my app because, it's cloud native. And I've used the native version of it. So I've used with Grohl and Quarkus in Java 17. So that's the magic behind it. But I think there's also other annotations available in other frameworks as well. So it's not something specific.
Okay, thank you. I got another quick one. If the pods are not ready, isn't already the kubelet to remove that pod from the respective service? Is it really needed something big like Istio for this?
Normally, you'd say that would be enough, but I would say that extra safety net coming from Istio is always great to have. It's what you are exposed that you're monitoring your systems. So even sometimes having a small unavailability situation can be really bad and can be really upsetting. Not just, maybe end users will not see it, but that translates sometimes into some business impact. It maybe be seen as little, but let's just say that there are situations when you don't want to lose anything, and that Istio is there to give you the extra safety when it comes to that. And let's just say that in case that you're working for applications for banks or for insurances and so on, you don't want to miss anything, or you don't want just to rely on the default. And I think that at the moment we are pretty much concerned of not missing anything and not failing at anything, and that's why we have so many on top of Kubernetes, to cover all the scenarios that can go not so great.
Okay. We have a couple more questions. So if you can maybe join the chat and
yes,
answer.
I will.
Yeah. or
No
in
worries.
direct message if you can. So thank
Sure.
you again, Anna Maria, and goodbye. Ciao ciao.
Thank you. Bye.
Bye bye. Torno all'italiano che mi è più congeniale. Allora, facciamo una breve pausa adesso. Abbiamo circa 10 minuti, quindi alle 11 riprendiamo con il KCD. E state all'occhio in chat adesso perché dovrebbe arrivare il link per il form delle magliette. Le magliette, ok? Ci vediamo alle 11. Ciao ciao ciao.